Okay, so this is lesson 10. We are skipping ahead a little bit because lessons 6 through 9 basically just talk about how to do everything with technology, but we've already learned how to do that kind of simultaneously with our other lessons. So we're just going to jump right into lesson 10. So we need to start with our goal over here. So if you need to, pause the video and write those down. It's important that you write those goals down so that it kind of sticks with you as we're talking throughout the lesson. So what we're going to be doing today is talking about, we're going to recognize that there's a relationship between the mean and the median based off of the shape of distribution. Okay, so in previous lessons, we've talked about the mean, we've talked about the median, and now we're going to talk about how there's a connection between those two things. Okay, so let me move on down here. Okay, so just a reminder, let's talk about the different shapes of distributions. That's back in lesson 4, if you want to refer back to it. That's where it talks about the shapes of distribution. So some of the ones we talked about were skewed. We talked about symmetrical. We talked about uniform. We talked about bell-shaped. And then finally, we talked about bimodal. Okay, but in this section, we're mainly going to be focused in on these two right here. Okay, when we're talking about the shapes of distribution. Okay, but it is important that you do know these other terms and what those mean. We're also going to understand the effects of extreme values on the mean and median. All right, so when I'm referring to extreme values, I just mean really high values or really low values in the data set. Okay, so if I had a data set that was 1, 2, 3, 4, and we graphed it and all that kind of stuff, and then I added in like 203, okay, that would be an extreme. Okay, because it's just really large and different. It's gonna affect that data set. Okay. All right. Now, starting in with our lesson, we're not actually even going to do 10.1, so we can skip it. Going on to 10.2. All right. So it says, use technology to create a dot plot that represents the distribution of the data, then describe the shape of the distribution. Okay, so what you're going to do is we're actually going to skip this, or wait 1 second, my computer's glitching out. Okay, I'm going to use this other app that I used when I first taught this, because I've already taught this to 2 of my classes. I'm going to show you this little app. Y'all don't have it, but it's fine. It's just a quick way to see what we're doing. So let me go to it real quick. I already have this pulled up, and then my computer decided to freak out and I had to restart it. So forgot to pull it back up. Okay, here we go. So here is that data set from 10.2. So we're going to look at it graphed. So this app does that for us. So I want you to take a second and I want you to describe on that first part what this shape of distribution is. Okay? So based off those 5 that we just talked about, what would this shape of distribution be? Okay, so I'm going to go back to my notes. I'm going to be like going back and forth between that, so bear with me. If you described that shape of distribution as bell-shaped or symmetric, then you are correct, okay? But like I said earlier, we're really gonna we're really going to stick with this one. It is bell-shaped, but symmetric is kind of where what we're going to be using a lot to describe it. Okay, and then it says it wants us to find the mean and the median. Well, we know how to do that in our calculators by finding the 5-number summary. Okay, so I'm just going to pull that up. Got my list right here, already pulled up. You forgot how to get here to this list. Remember, you just hit second stat. Nope, just stat, enter, and then we're going to type it in. So 6, 7, 8, 8, 9, 9, 10, 10, 10, 10, 11. Okay, so there is my data set. We're going to go to stat, calculate. All right, so according to this, our mean is 10. A little X with the line over it was 10. We'll scroll down, and our median was also 10. Okay, so I want you to make a quick observation with me here. So when our data is symmetrical, which is how it's starting out, this original data set is symmetrical. What do we know to be true about its mean and median? They're the same, okay? Because all of that data is, you can kind of see it right here on my graph, you can see that the majority of that data is near the center, okay? And the mean and median are both measures of center, okay? So it's describing that all that bulk of data right there is at the middle of the graph, and it's symmetrical. Okay, so moving forward, we're going to kind of be bouncing back and forth between this graph and our paper, so I'm just going to leave it kind of pulled up like this. It says, once again, we're going to find the mean and median of the data with 2 additional values, okay? So when it's talking about these 2 additional values, these values that we're going to be dealing with in this are our extremes, okay? Just like we talked about in our goal earlier, okay? So let's look at this. It says we're going to add 2 values to the original data set that are greater than 14, okay? So we're going to add 2 values, and it wants us to find the mean and the median, okay? All right, so let's go back here. We're going to add in values that are greater than 14. So I'm going to do 30, or I'm just going to do, I won't do even 30, I'll do 18 and 25. Okay, so we can look right here at our mean. All right, let me start over real quick. Okay, so here's the original. We can see right here on our graph that the mean and the median are both right there in the center. All right, so when we add in these extreme values that are higher, like 18 and 25, let's see what happens to our mean and median. Okay, so if I'm looking here on the graph, the median is still 10. And then what happened to the mean when we added that higher value? It became 11.15. So let's go over here and write that information down. Okay, so the mean is now 11.15. Remember, it was 10, and the median is 10. So let's make a quick observation. So here's our mean. This was our mean. What happened to it? It went from 10 to 11.15, so it increased with this larger value, okay? So when we have larger values, the mean is going to be greater than the median, okay? When we add in these values over here, like these larger numbers, okay? And then when we added in those larger numbers, what happened to our median? This is our median, this was our median. it stayed the same. Okay, so that's my observation with that. That's all I noticed right now. So let's see what happens when we keep going. So once again, we're going to do our mean and our median. All right, I'm going to take these values out. Okay, make it go back. And this time, it's wanting us to add two values that are less than 6. Okay, so I'm going to go in there and add them on to the end. All right, so I'm going to add -5 and 2. Both of those numbers are less than 6. All right, so looking over here now, my median is this little blue circle, my mean is this little red circle. So now look what happened when I added in these lower values. What happened to our mean? It started at 10 and then it decreased to 8.85. So let's write that down. So it went to 8.85. And then my median is still 10. Okay, so this time I put in two values that were less than 6, so I put in lower extremes. Okay, so even though it's a smaller number, it's still considered an extreme. What happened to my mean? It decreased, okay, from the original, which was 10. All right, and then we have our median, and it once again stayed the same. So are y'all starting to see a pattern? What I'm noticing is that these high numbers, these extremes, and these low numbers, the extremes, it's really affecting my mean each time, okay? It's affecting my average, but those high numbers aren't really doing much of anything to my median because it's staying the same each time, okay? Going back to my thing, it says it wants us to add one value that is greater than 14 and one that is less than 6. Okay, so I'm just going to stick to something that I had, -2. And I don't know why it won't just let me click. And we'll do 17. Okay. Let me do a little bigger, 25. All right, so not that it even mattered any. Okay, so we're talking about the mean and median. So once again, it did change up my mean just a little bit. I have 10.15, and my median is still 10. So yet again, these numbers are the median is staying the same. These extremes are affecting only my mean each time. All right, and then finally, it wants us to add in 50 and 100 to our data set. 1 second, I have to go all the way down here and delete the -2. And we're gonna see how doing that affects the mean and median once again. All right, and if you were to make a prediction on this, I would have probably said that the same thing would happen. When we added this high number, our mean increased from the original, which it did, 16.5, started out as 10, and the median is still the same. Okay, so what I'm seeing is it wants us to, what do you notice is happening with the mean and median based on the additional values? Okay, so let's make some conclusions. Let's draw some conclusions here. Okay, so I've got mean, got the median. Let me zoom in so I can write. All right, so take a second, maybe pause the video, and what's your observation that you notice about the mean? Okay, what did you notice was happening every single time? I noticed that when we add larger extremes, my mean increased. And when we added smaller extremes, my mean decreased. Okay? We'll take a second, pause the video if you need to. All right, and then we have our median. Okay? So every single time, it didn't matter if we added 100 or if we added a large negative number. What happened to our median every single time we added these high numbers and low numbers? Nothing. Okay? So the median didn't change with high or low numbers. Okay? All right, so part 5 says change the value so that the distribution fits the description given to you by your teacher and then find the mean and median. We're actually not going to do number 5, so we're just going to skip that one. And we're not really going to do number 6 either, but we are going to draw some more conclusions down here, kind of like wrap it all up and tie it in a bow. Okay? So what we've talked about from our goals is that based off of the different distributions of the data, we're going to look at certain measures of center or the mean or the median. So when I looked at data that had really high highs and really low lows, so look over here at my graph. If I zoom out and I can see those values that we added in, at 50 and that 100, it took my data from being symmetrical, like we talked about at the beginning, and when I added in those numbers over on the sides, my data became skewed. Okay? And my data becomes skewed when I add in those high numbers and or low extremes. Those extreme values cause it to become skewed. And we talked about which was the only value that didn't change when my data became skewed. It was the median, right? Okay, so if I'm ever looking at a distribution and the data is skewed and it wants you to find the typical number, it's wanting you to find the median, okay? Because that is going to be the value that is not affected by those high numbers and low numbers, okay? If our data is skewed, we've just seen in 4 different examples that the mean every time was changed, okay? So that's not going to be a really reliable number when we're trying to draw information from it because it can so easily change by the extremes, okay? So what you need to know is when the data is skewed, you're looking at the median, all right? Then, if that's the case, if our data is symmetrical, then you are going to use the mean to find the typical value, okay, to use it to answer any of the questions. All right, so that's like the big thing that this whole lesson is wanting you to see, okay? It's wanting you to see why you use median with skewed and why you use mean with symmetrical, okay? Because the mean always is so easily, is so easily affected by the extreme values from skewed data. Now, this wasn't anything we really talked about in this lesson, but these are measures of center. Measures of center. Okay, so these are the two different measures of center that we talk about. With those, they have their own measure of variability that goes with it. So when we're talking about the mean as our measure of center, we're going to use the MAD as its measure of variability. And that makes sense because it's the mean and the mean absolute deviation. Those two go together. Okay, so then that would leave the IQR as the one that goes with your median and your skewed data. Okay, and we're going to explore that more in lesson 11. Okay, so that is your big conclusion from this. All right, now we're going to do our lesson summary really quickly. There's not a whole lot to highlight. All right, so, all right, it says, is it better to use the mean or median to describe the center of data? Okay, that's what we've talked about in this lesson. And again, we do it, it's based off of the shape of the distribution. So in the second paragraph, it says the mean gives equal importance to each value when finding the center. Highlight, second sentence, the mean usually represents the typical values well when the data has a symmetric distribution. So there it is again. We use the mean when it's symmetric. Okay, next paragraph, the median tells you the middle. So changes to a single value usually do not affect it as much. So highlight, the median is more appropriate for data that is not very symmetric. Okay, so there's those two really important things. Okay, I believe this is on page 70 if you're lost of where this is at. Okay, so we're going to skip down a little bit. I'm not going to read all this stuff because I feel like there's just a lot of words to really just show you the most important part of this right here. Okay, but I do want us to look at a graph, these two graphs. Okay, so it says, here is a dot plot showing the amount of time a dart takes to hit a target in seconds. The data produces a symmetric distribution, and we can see that, okay? If we were to split it in half, then it's pretty similar on both sides. Therefore, if we have a symmetric distribution, according to this, what measure of center are we going to use? The mean. And if we're using the mean as our measure of center, then we're going to use the MAD as our measure of variability. Okay, moving on down. Here's another graph on your next page. It says here is a dot plot using the same data, but with two values changed, resulting in a skewed distribution. And we can see that it's skewed because we have this tail-like part of our graph that's pulling the data in the other direction. Okay, so if it is skewed and we have those low values, those low extreme values are going to affect the mean more. So we don't want to use it if it's going to be so easily changed. Therefore, the center measure of center that we're going to use is the median. And then that would mean we would also use the IQR. Okay, so that is our big takeaway from lesson 10. Okay, this last part you actually don't have in your book, so if you're virtual, you just are going to have to pay attention. If not, I mean, there's no other way you can get this sheet of paper. Okay, so you need to pay really close attention to this because this is a good little review. So it says, and number one, is the mean greater than, less than, or equal to the median? Explain your reasoning. Okay, so what I'm noticing here is, first things first, I noticed that my data is skewed. Okay, we have this tail, is what it's called. This tail of my graph a lot of higher numbers that is pulling my data in that direction towards those higher numbers. So thinking back to the activity we just did, what happened to our mean when we added in those higher numbers? When we added in those higher numbers, our mean increased, right? Started out, if it was symmetrical, the mean and median were the same, but if we added in those higher numbers, then that caused it to increase. So if my mean is increasing, is it greater than, less than, or equal to the median? It would be greater than, let's say the mean is greater than the median because the higher numbers are making the mean increase. Okay, moving on to the next one. It says, is the mean greater than, less than, or equal to the median? Explain. Okay, so first of all, if I'm looking at this data, we need to look at the distribution because we said from the beginning in our goal that there is a relationship between the shape of the distribution and the mean and the median. Okay, so the first thing I notice is that it's uniform, but more importantly, it's symmetric. Okay, so if I were to divide it in half, it's going to be very similar on both sides. Okay, so like we talked about at the very beginning of that 10.2 exercise, when our data is symmetric, we know that the mean and the median are the same. Okay, so would the mean be greater than, less than, or equal to? The mean would be equal to the median. Oops, because the data is symmetrical. Okay, and it's as simple as that. All right, so that's all I have for lesson 10. The homework is already posted, so go ahead and get started on that. It's due Sunday. If you have any questions, just let me know.